Hi guys, thanks for having me today. So a little bit about myself. So I've done quite a lot of Kubernetes now, working in the consultancy space for a number of different projects. And what I've gained an interest in over that time is how you can go about unifying the overall experience for developers going across their local development experience, then going into or moving that workload into a production-based environment. And how you can get closer to a scenario where developers are ramped up enough on Kubernetes to actually be able to support that type of workload. So what I'm going to be doing in this talk is talking about the benefits of running everything within Kubernetes and keeping kind of a consistent interface for pretty much everything associated with CI and CD and facilitating continuous delivery. I'm then going to go down, I'm then going to run through the tools available to us within the Kubernetes ecosystem, and there are a lot. And then finally, kind of go about doing a demonstration of a subset of those selected tools that can act as a potential option in going about doing a Kubernetes-centric CI/CD workflow. Because there are so many options, I'm just going to do this quick little kind of example of one, and then you can probably take away like it as an approach. And it's also an open source repository that I'm hoping to extend and add additional demonstrations. So take nothing that I say in the how component as very opinionated. There's just such a large array of tools. I'm going to be just touching on some of them. So if we start off with the why, so if we look at why you'd want to run a Kubernetes-centric workflow, if we look at the benefits we get from the Kubernetes controls, we have things like RBAC, which if I can just get a show of hands in the room, when I say RBAC, how many people are actually familiar with what that means? Okay, so a decent number of people are kind of getting across that core concept. So what we have the ability to do is kind of do that fine-grained authorization of how you can go about deploying resources within Kubernetes. And what this facilitates is you creating really nice demarcations in access when you're creating or running a pipeline and giving it certain permissions to deploy workloads within your cluster and what you're granting it the permissions to do. In addition to that, you also have network policy. So you've got the ability now to also control things on a network layer. So you've got a pipeline that might have the permission to deploy a workload, but it won't have the permission to necessarily talk to it from a networking perspective. And so this can get you closer to giving more control from a security perspective over how that pipeline can then be like locked down from a security perspective. So another big benefit as well when you run everything in this kind of pull-based model or a push-based if you're using webhooks is that you don't have to actually give access to an external system, so like a Travis CI or a Circle CI. You won't have to give it hard-coded credentials to actually give it the permission to deploy to your Kubernetes. Instead, you'd have an operator or a controller running inside of your cluster that would then go about pulling down from a source code repository the required configuration and then applying that to the cluster, where that operator or controller runs within the Kubernetes perimeter, and you can then apply those fine-grained RBAC permissions and network policy controls. You, in your CI/CD pipelines, can then utilize Dockerless building, and we're going to touch on the range of tools available to achieve this, to go about then deploying, or rather building workloads during CI without having to give root-level permissions to Docker, for example. Which can lead to vulnerabilities, and you won't have the ability to utilize pipelines in that untrusted fashion as much. So another one to touch on is the idiomatic nature of using something like Kubernetes, which is very declarative. You can kind of come across or build up a standardized approach to going about doing pipelines, going about building up the developer workflow. So because everything is YAML, and I'm not saying YAML is necessarily a good thing to work with, you can at least go about trying to standardize on it, template it, and build a common experience for all of your developers and for the platform team to go about deploying workloads. So the big benefit is then you can bring in tools like Helm, Kustomize, and Capitan to go about doing that templating aspect. So to touch on the developer experience, so I touched on this right at the start, but it's how you can go about getting the developers closer to being able to ramp up on running a production-based environment. So if you can get a scenario where their common workflow involves deploying to Kubernetes, then they can also more easily reason about then when they're deploying to production or a staging environment. And you can get very close to a unified environment locally as well as remotely in a staging or production environment with just some variable substitution acting as the difference between those different types of environments. And so, as I just said, the big thing you get from this is a closer experience to the realities of running workloads in production. And so if you do have an ethos of you build it, you run it for your developers, they'll be in a better position to actually go about supporting those applications, triaging it, and working with potentially a DevOps or SRE team to debug and understand the root cause of issues that might come up. Another thing that I didn't touch on, but I just realized now, another good one you get as well is that if you need to have certain dependencies added as part of your integration testing or development process, so one example would be Istio, you can actually then go about representing that same type of dependency within your developer workflow. So for example, if you're doing integration tests, how do you actually bring in the dependency on Istio? How do you make sure that when you're running tests, you're actually factoring in that it's running over a service mesh, for example? So to look at the how, so there are a large number of tools. So what I'm going to run through is the different kind of aspects of that CI/CD workflow and what the options are available in the current ecosystem, and a very small subset of them, by the way, and how we can go about kind of navigating the different options. So if we look at the different features of different builders, so you've got the standard incumbent Docker, where it has instruction caching, but it's fairly limited. But if you look at BuildKit coming out of Moby, that has a more richer overall capability, where it will also utilize or give you the ability to do parallelized builds, as well as allowing you to do Dockerless builds and rootless with some exceptions. You then have IMG. So IMG is built on top of BuildKit, and that is effectively just a wrapper, a small wrapper around BuildKit that allows you to go about doing the whole building workflow. And you can effectively replace Docker, the Docker command or binary with img. You can effectively do like an alias command and you get the same capability. So we then have Builder, which is another option. And then you've got Kaniko finally, which is the tool that I'm going to use in the example today, which comes out of Google Cloud Platform tooling. And it supports a similar thing where you might want to do Dockerless builds and support untrusted, or you don't want to necessarily give privileges to the binary that's actually going about building a container. Finally, next we have pipelines. So if we look at the features or the available options there, we've got Jenkins, which is another big incumbent, a very old tool, but has some modernized options available to it with the declarative pipelines, as well as the pod template plugin, which allows you to then deploy workloads to Kubernetes. You have Jenkins X, which looks to try and bring a more more Kubernetes native approach to the whole problem of building CI/CD pipelines. You then have Argo, which is another big tool that's starting to gain a lot of traction and a lot of popularity. And it's another tool that I'd like to add into the repository I'm going to demo today. And then we have Tekon, which is what is going to be demoed today, which, as you can see, has a very similar feature set or capability as what Argo brings to the table, where Tekon seems to want to kind of create a standardized set of tools or common building blocks in actually enabling you to build CI/CD pipelines in a little bit more of a low-level fashion, giving you then the opportunity to potentially abstract or surface a different API or interface to go about then building pipelines. So for example, you could abstract it into a nicer experience for users. And then you have Spinnaker. So Spinnaker being a pretty big monolith, or not monolith, rather a microservice, but quite complex CI/CD tool, and is very feature-rich, so it's an incredible tool, and I've used this quite extensively, and I have really enjoyed using it, but it is quite a complex beast, and you will spend a lot of time trying to manage it and kind of come up with a good workflow with it. You then have Weaveflux, which is a similar lightweight option. Now with Weaveflux, Tekton, and Argo, as well as Jenkins X, they have a nice mechanism where they follow like a controller or operator paradigm, where they can then use like a commonly known as Git flow workflow, where you'll be able to bring in changes based off Git pull request and other changes, or Git events. So looking at the developer experience, we've heard a talk today on a developer tool. Some of the options you have in the Kubernetes native work environment is you have Skaffold, which is what we're going to be running in the demo today. So Skaffold aims to kind of treat the deployment experience of a number of different dependencies in a similar way to Docker Compose, but instead you're targeting a Kubernetes cluster instead of the Docker daemon. You then have Tilt, which has a very similar feature set, but it has a nice GUI to it. So you can nicely navigate and interact with your overall running environment. You then have Garden, which has a similar kind of approach, which enables you to kind of see the whole dependency structure of your deployment and facilitates similar features as the other two, where you can do hot loading. You can also kind of interact with the deployments and the logs, and it just helps a developer unpack what might be going on in a Kubernetes-based environment. Okay, so we got through that pretty quickly, and that's because I wanted to spend a decent chunk of time actually trying to demonstrate what I am trying to position as a potential workflow that a developer might go through, just as a hypothetical. So if I just jump into the CLI here, actually before that, I will run through the CI/CD pipeline that we're going to be constructing in Tekton. But before we actually go into that, that's going to be the final stage of our kind of developer workflow where we want to deploy something to a production environment. So how this works, how this CI/CD pipeline is going to work that I'm going to demonstrate is that we're going to raise a pull request in the final stage once we've done all of our integration testing. We've done the stand-up of all of our dependencies locally, and we've carried out our tests. When you raise a pull request, that's going to trigger and hit a Tekton webhook. That webhook is then going to go about constructing a pipeline run. So a pipeline run is effectively a custom resource definition in Kubernetes, and it allows you to effectively call then a pipeline. So a pipeline is just a set of steps, and so those steps are shown underneath that pipeline run. So for example, I'm going to be carrying out my linting, unit tests, and integration tests, and then build the front end, build the back end, and finally deploy the application to production using a combination of Skaffold and Kustomize for the templating aspect of it. So let's jump into it. So it's a Golang-based application. So as you'd commonly have in a developer workflow, let's say you need to do some unit tests. So here's an example of the unit test that I'm running. We can see here, this is just a little lightweight amount of unit tests that I have. And then you've got integration tests, where integration tests would be carrying out your actual database calls and interacting with your given environment and kind of doing a little bit of a deeper check with everything. So one of the things I just need to check here is that we've got caching happening with Golang, because I actually wanted that to fail. Can anyone help me out here? Who knows Golang? How do I clear the cache? So Golang will cache test results. I want to clear those. I've got a previous command. I don't know that one. Okay, so what I'm going to do is I'm just going to show you what I was proposing to show. So if I now go, so I'm going to be showing off a bit of Skaffold here. So Skaffold gives me the ability of deploying everything from what they have as a concept of profiles. So with a profile, I can represent a given deployment environment. So what I'm going to do here is I'm going to represent running Postgres locally. So if I do deploy-profile, and then if I go Postgres, local-Postgres, this is going to go about deploying my Postgres instance locally. And then if I do some port forwarding to that Postgres instance, I should then be, like what I was going to try and show is that if I then ran my integration test, they would pass. Whereas because I've got some Docker caching, some Go test cache results happening right now, it's passing even though that port forwarding wasn't active. And so what I was going to be demonstrating through this workflow is how at the very first step, you might want to be able to go about deploying a single dependency where you start with Postgres. You then can still run your tests with, for example, a Golang application out of band of running that within Kubernetes. The next step we're going to jump into is how we can then progress to running effectively, as the earlier talk kind of mentioned a little bit, about how we want to run some extra dependencies all within Docker. So one of the things I'm going to do next is I'm actually going to deploy the entire stack, which will consist of a small React front-end application that talks to the back-end. So the unit tests that I was running just then were against a Golang-based back-end application, which effectively fetches products. So I've got a Golang app, and it's fetching me products, and I'm going to now put together the whole end-to-end stack that's going to show them for us, and we're going to go to the UI component of that. So if I go make local dev, so that whole bunch of stuff that just got piped out into my terminal is effectively the Skaffold output. What I'm editing here are my local etc host files so that I can actually resolve this on a nicer little domain. So we can see here I've got products.demo.local. So that's made possible through etc host. Let me zoom in a little bit there. So if we just bear with me, that's just some are failing. So we've got the logs coming in here, so we can see the interaction with that back-end application. The logs of that are being piped here. And if we keep refreshing this, we can see we're now running this end-to-end application locally. So to make that kind of make a little bit more sense, if we go kget pods in this dev namespace that I've just deployed to, I have all my dependencies kind of tied in here within this local environment, within this local Minikube cluster. So I've got my Postgres application. I've got my products backend application. That's the Golang app that I was just running those tests against. So I was running some integration tests and some basic unit tests. And another thing to touch on as well is within the unit tests, another thing that, and I just forgot to mention this, but another thing I wanted to touch on is that I have tried to also demonstrate how we can decouple even the dependency on the Postgres instance, where I actually am carrying out some SQL mock testing on the given Postgres instance, so that we can actually get to a point where the very final stage would be what we're doing now, which is doing some basic final tests before we do the pre-commit, before we actually raise the pull request to actually go about deploying this potentially to production. So the idea would be you would deploy to production, or you'd raise your PR once you've actually done the final integration test, which actually go about standing up the full end-to-end stack, and you're more confident about what's running and what you expect from it before then moving on to the production deployment. Okay. So what I'm going to demonstrate next is we've got our little front-end application running here. So as I refresh, it's on products.local. What I'm going to show is the hot loading capability that these developer experience tools provide. So if you just take note of the branch that I'm on. So I'm on feature/products. So let's say this is the first release of the application. This is the MVP. What I'm going to demonstrate next is how we could then propose to move to V2 or a new feature. So we've got the hot loading of Kustomize running here. So what Kustomize is doing is it's looking, what Skaffold is doing is it's looking at the file system and it will look for any changes. If there is a change, it actually can automatically trigger and resolve what containers it needs to build, as well as then triggering, if you do have an interpreted language, the copying of content into the actual running container to even further optimize the time spent doing builds, for example. So if you had Python or a node-based app, it can actually copy the content directly in. But in this case, what it's going to have to do, because it's a Golang app, is actually recompile. So I'm going to show what happens when we switch branch. And when I switch branch, I'm going to be switching into the ratings feature. And so what we're going to be doing is we're going to be showing how we can move into V2 of this application and what Skaffold's going to do for us behind the scenes in terms of the hot loading capability. So I've just changed into a new branch, which has some different content in it. It has some additional code. It has some new features. And so we can see here, we just saw a bunch of logs pump out there. And if we have a look here and we refresh the page, so we now have ratings. Now note the first set of stars we see here is some preloaded data that I load in as part of the Postgres bootstrap, and that's part of the integration test. So there's just some preloaded data here, and that's just for testing. But for example, if I interact with this here, so I'm clicking on stars, this data is being persisted in Postgres. So now if I refresh the app, we can see those stars are still there. And so this is an example of I've now rolled out a new feature, or I'm potentially testing someone else's work on a feature release, And I'm able to kind of represent all of those dependencies in a really idiomatic and reproducible way, or at least that's the goal, where I would be able to check out their code and immediately run a potential entry point script that would run that scaffold command that I just ran then, and then you'd be able to reproduce it and stand up everything locally and see the expected results or go about validating whether that's meeting the expectations. So we've now validated everything locally. The next thing we're going to do is we're going to go about deploying this to a staging environment and carry out the same approach we're doing here, but we're going to see the hot loading capability in a more staging or non-production based environment, where Skaffold is now going to target a cluster that I'm running in GKE and carry out the same kind of deployment approach. Okay, so this is local. The big thing to stress here is the domain here. So that's just a local thing managed by my etc host file. If we go over to this domain, so that's products.nonprod, and then I've got some main domain over here. So if I refresh this, we can see I'm still on let's say V1 of the application, or I'm still on the products version of the application. What I'm going to do next is I'm going to show how we can update that. So this is, again, running in a Kubernetes cluster. The ingress to this cluster is enabled through Istio. So I am running Istio here, but I'm going to skip over those details as it is a little bit more of a complex topic and possibly could be a talk of its own. The main thing to take away here is that the reason why I think it's good to have this staging environment before then raising that PR is that what if I need to actually carry out those same integration tests, but this time factor in potentially the interaction with Istio? Have I got the right policies in place? So what if a developer wants to edit the Istio policy and actually have some sanity check or a mechanism of validating that that isn't going to actually break the ingress, it's not going to break the interactions with other dependencies within an Istio service mesh? They can do so by deploying to a staging environment in a fairly flexible way, carry out their necessary integration tests. Another thing they could also be doing is some performance tests. What if you need to factor in the network latency of those extra proxies within the service mesh? You can go about carrying out those performance tests after having done that initial staging-based deployment. So let's deploy now to this non-prod environment, and we should see the rollout of those stars that we see in our local environment into non-production. So another thing to note as well here, when I cancelled that command, the Skaffold tool has actually gone about cleaning up my deployment. So it's gone about deploying all of those resources that were associated with the locally running environment. And so if I go and check what's running now in that dev environment, we see it's terminating. So everything's cleaning up here. We had those 3 deployments. They're all in the process of being cleaned up. So effectively, you can nicely garbage collect anything you have deployed into Kubernetes, where you might have a number of different dependencies, and you might want to be able to clear those over time. So now let's deploy to our remote environment. So if we just look, and I'm also showcasing here like what you could do to try and wrap all of these commands or things that you might be trying to standardize on. One example is to utilize a make file, where you might have common entry points for different activities. So the one I was using before to do that local development is local dev. And so this has quite a lot of stuff in it, but it's nothing too important. But the main thing here is I've got an entry point which represents the local deployment, and I've got another one which represents the more staging-based deployment. So let's kick that off. So Skaffold is going to go about doing that whole build. It's going to push those images to GCR so that those images will now be available for our Kubernetes cluster running remotely. And then it's going to go about deploying all of the required resources. Now, these resources are, when I say resources, I mean the deployment, the service, all of the things required to have that Kubernetes environment support your given application. So in this case here, we see it deploying, and we can see it has these unchanged. So there's a lot of things that are unchanged here, but the thing that has changed is our backend application. So that's why it says this is configured. And so if we look at what's happening right now, we can see here the one thing that did change out of that deployment, whereas before we've just seen that it is currently working, but it was on V1. And that's why this has been running for 3 hours, as it's something I prepared earlier. But this time, we have changed something about the backend, right? We've deployed a ratings feature. We now have some new kind of capability we're introducing into the cluster. And so Skaffold has automatically worked out that it needs to redeploy the backend application. And so that's why it's been alive for only 29 seconds. And so now when we go to the non-prod application, we refresh, hopefully we see the stars, then we do. And again, we see that sample data pre-populated here for the rating. And you can all, by the way, browse to this endpoint, and you could technically add ratings. And when I refresh the page, I would see your ratings of these different products. So if you want to go and give that a go. But if I just pop some in here, these are all being persisted in our database. So for example, if you're all connected to this right now and tried to effectively DDoS this little application running with just one instance, this is kind of like a live staging environment. So you could also have this as like a way of socializing change within a kind of development workflow. So you could quickly deploy it to staging. You can then go about socializing the proposed changes before then moving on to deploying that into production. So we're now at a point where we've deployed this locally. We've gone about fleshing it out and working through validating that it meets our requirements. Now it's time to kind of look at deploying this to production. So what we're going to do now is we're going to actually raise a PR on the GitHub repo that holds all of this content, which is publicly available, by the way. So if you come here, you go to Kubernetes CI/CD, and we're going to raise a PR. And this is going to go about triggering our Tekon deployment. But before we do that, let's just have a look at what's actually in production right now as well. So instead of products.nonprod, now it's products.prod. So if we refresh there, we see that we're still on V1 still. So we haven't deployed to production yet. We're going to now deploy to prod, but this time, of course, production's a little bit more sensitive. We want to carry out some more robust checks. We want to do some more validation. So this is going to be done through now an actual CI/CD pipeline using Tekon. So if I go raise this PR, I can see a lot of traffic coming in here. I can see you guys are hitting it. Let's have a look at non-prod. Wow, someone's really smashing those ratings. Nice. But you haven't brought it down yet, so try harder. Okay, so let's deploy to prod. So I'm going to raise a PR, and I'm going to raise a PR from the feature/ratings branch. And to kind of just, to give you a quick walkthrough of what's actually happening in this PR, is I'm pretty much adding an additional field in the struct, and I'm calling an additional function, and this function returns ratings. And so what's happening is the front-end application I've developed, this React app, pretty much just looks at the payload and says, oh, there's a ratings field, so I'm going to render the ratings. And if there's not a ratings field, then it doesn't render anything. And that's how we're kind of doing this rollout. In a more production-based environment, you might do this using feature headers or feature flags. But this is just a pretty contrived, fairly trivial example. And so what we're going to do here is we're going to actually raise this PR. And this is going to trigger some events in our Kubernetes cluster. So if we go k-get pods in the Tekon pipeline namespace, and we watch those, we can see here that just recently a webhook was initiated. And so this scales to 0 because it's done through Knative. I don't know, can I get a quick show of hands? How many people have heard of Knative? Okay, cool, that's cool. How many people have actually played with it? Okay, smaller subset. So this is Knative in action here. This was a deployment that was scaled to 0. When GitHub hit that API endpoint, Knative was able to scale that up from 0, and it was able to then service the request from GitHub. And then what the next step of that was to do was to then trigger the creation of the pipeline run, as I had in my example. And so that's why the subsequent action was to carry out this CI/CD pipeline in its statuses. So now there's a whole bunch of stuff that has gone by since I was just describing that. But if we have now a look at our Git repo, we can see there's a bunch of checks that have just initiated. So these are the checks that are being initialized by our Tekon CI/CD pipeline. So for example, we're making sure that the unit tests have passed, that the integration tests have passed, and that linting has passed. Ignore this deployment one, that was just from a previous run. But we also want to be able to check that the build was successful and the front-end build was successful as well. And so this is an example of our CI/CD pipeline interacting or making callbacks to the Git repo to provide feedback potentially to a developer on the success of that deployment. Have there been issues? Was there issues with integration testing, linting, whatever it might be? And so if we actually have a look at where that's all coming from, what we can use to get visualizations of how that pipeline's running. So this is the Tekon UI. It's in fairly active development. But what we have here is a kind of uniquely identified pipeline run. And if we select that, we can see there's a bunch of steps that have been initiated. So this is my CI/CD pipeline, where this was all represented as YAML. So we can see here that we've got a number of different steps here. We've got the integration test, we've got linting tests. We can come in here and see what's actually involved in this. So as part of the integration test, it'll ephemerally spin up a Postgres instance. It will then wait for that Postgres instance to start. It'll then run the integration tests, which are dependent on a running Postgres instance. It'll then go about destroying the Postgres instance. And finally, it'll update the GitHub status. And that's where those statuses are coming from when I go and look at the GitHub UI. Each one of these steps on a successful completion is making a call to the GitHub API and updating the status accordingly. We then have things like linting happening. So this is just running the Golang meta linter. We then have our unit tests running. And now we are waiting for our build of the front-end and back-end application. So if we have a look at what's happening here, we've got the front-end building, and we've got the back-end building as well. And so once those have successfully built, we should then have the deployment get carried out, which will deploy it to our production environment. So if we have a look at what some of that YAML looks like, so it can be pretty scary to look at this. So we've got a pipeline resource. So a pipeline resource, while we wait for that CI/CD pipeline to run, because obviously it's pretty boring to watch that, we've got pipeline resources, which is a Tekton construct, which represents effectively a resource that the pipeline is going to need to consume. So in this case here, it's consuming a Git repo. And to jump through a whole bunch of pipeline code, we then have a task, which represents those kind of more atomic actions you might be taking or a given step you might be taking during a CI/CD pipeline. And if we jump right to the end, so we can see here that pipeline consisted of if we look right at the end, we've got up to 500 lines of YAML. So obviously you don't want to be managing that manually. So the whole premise of running everything as YAML or having everything defined as YAML is we can quite quickly start abstracting, templating, and kind of building on top of Tekton, given we've got these nice building blocks, these nice fundamental lower level building blocks. So to go back to the other constructs, we've got a pipeline. So a pipeline is the mechanism by which you specify which tasks to run during a CI/CD pipeline. And then finally, the thing that webhook was initiating was a pipeline run, which is then responsible for calling a specific pipeline reference and triggering and passing parameters and resources to then go about actually doing the build of your given application. So we can see here our checks still haven't passed. If we have a look at Tekton. Oh, another thing to touch on here is the cool thing about running everything in Kube, right, is that all of these pods being spun up to run those given steps can be torn down afterwards, so you kind of have this nice scale to zero aspect of your given environment. All of these pods can be given specific kind of permission structures. You can control how they can talk to other things within your cluster, and it can run things parallel, like it's highly parallelizable. So if we have a look at the Tekton dashboard again. Okay, so cool, we're still building. It's going to take a while. And what we'll hopefully see at the end of this is that my production deployment has been upgraded to have stars on it. And so in this case here, it's a very trivialized example because you wouldn't necessarily do a direct deployment to production on a successful completion of all of those checks. Instead, you might follow a more GitOps pattern where on a successful completion of all of that, you would generate your manifest, so all of your resources that you want to deploy, and you would then commit those to another repository, and then that would trigger another Tekton pipeline, for example, which would then go about deploying your given resources to your Kubernetes environment. You would then be able to do things like carry out some canary analysis, or some blue-green testing, and then have the ability to roll back if that deployment isn't proving to be successful. And then you'd be able to provide those that feedback back to the developer as well during that whole process. So in this case here, you can take this as a more contrived, trivial example that just goes about demonstrating a kind of use case or a scenario. And so cool, the backend's successfully built. And so we touched on builders. So this is that build stage coming in. So we touched on the one we're using, which is Kaniko. So Kaniko is just a binary. There is no Docker daemon running here. And it's able to consume a Docker compose file and output the given OCI compliant images for you. And in this case, we're pushing those to our GCR registry that we're then using to trigger to, or that we're then using in our given production deployment. So we're still waiting for the build of the front end. And that looks to have completed as well. And so if we refresh this, so then we've got this other step in here, which is deploy products. So we deploy Postgres, we wait for Postgres, we deploy upgrade Postgres, we wait for it to successfully complete, and then we deploy products. And so what this is doing is it's calling our Skaffold tooling, which is then subsequently calling our Kustomize templating, or not templating, but kind of representation of our resources. And the cool thing about this whole concept is that now you have the same kind of tooling being used in your local environment to deploy your local dev setup. You can use the same kind of tooling to then deploy your production-based resources in your actual production environment. And so now, if we refresh this, do we see stars? No, that's very concerning. And yeah, that's actually not done what I expected. So yeah, you'll have to forgive me for that. But the idea would be, you can see that successfully done a deployment. If we have a look at what actually was deployed into our, I mean, it could be this DDoS attack that's occurring on my cluster that's broken something actually. I can't really tell at this point. So if I look at what was actually deployed into my prod namespace, that's not responsive. Okay, it's pretty slow. There we go. Yeah, I think that's just not done what I wanted. So that pretty much brings me to the conclusion of this talk. I didn't get to touch too much on the specific constructs of Tekton, but I am trying to kind of construct inside of this repository a number of different approaches to the whole CI/CD journey and CI/CD story. And so it's contained within this repository. So for example, another thing I'd like to do as a future work is to experiment with Argo CD, and go about doing the whole same pipeline approach, but with other tools in that ecosystem that I touched on earlier. So that's it from me. Thank you for your time today.